Good evening. Ma'am, are you speaking?
Vaishnavi, what are you saying? Can you see my screen?
Yes, ma'am. I couldn't hear you till now, ma'am. So
Oh, I was muted. I was muted.
Oh, okay.
We have to identify what is the reagent which will convert hexanol to hexanal. That is the first one. The second one is parafluorotoluene to parafluorobenzaldehyde. Think of the reagents. Fourth one is allyl alcohol. Who will tell me the answers one by one? First one, what is the answer? Anybody? Three of you are there. Start answering. Vaishnavi, tell me the answer of the first one. How will you convert alcohol into aldehyde?
Ma'am, by oxidation.
By oxidation, very good. By oxidation. What is the oxidizing agent that you can use to convert to aldehyde, alcohol to aldehyde? Which is the oxidizing agent?
Ma'am, Cr.
See, if I take
Cr.
Cr2O7 and H plus, if I take, I will not get only aldehyde, I will also get the acid. So which is the one which I can use? PCC. What will PCC do? It will make only aldehyde and not the acid, right? So to prevent further oxidation, I can use PCC. Then here, this is a mistake. This has to be CH3. Now tell me, next one. Who is going to tell me the next one? Sanjay, tell me number 3. What is the answer for number 3? Sanjay?
Ma'am, number 3 is
it is also oxidation, but it is in presence of a special reagent. I told you what is a special reagent? CrO2, Cl2. It oxidizes CH3 to CHO, but not into acid. CrO2, Cl2, and H2O. Right? The next one is again oxidation. All these are oxidation reactions because we are using some alcohol or the other. Now this is allyl alcohol, but this is also oxidation. PCC. When you want to make only an aldehyde. Here also you have alcohol to ketones. Now alcohol to ketone, that oxidation is difficult. So here you can take Vaishnavi, K2Cr2O7 and H plus. You can even write it as Cr2O7 2 minus and H plus. So this is a stronger oxidizing agent that you need. Now cyanide to CHO. How will I do cyanide to CHO in a single step? How will I do it? We use a special reagent called Dibal H and H2O. Now last one somebody should say. I've explained in detail the last one. Sai Kalyan has come. Tell me, Sai Kalyan, what is the answer for the last one?
And is it ozonolysis?
It is ozonolysis. CH3, H2O, and zinc dust. Okay, so you have to remember the reagents, all the reagents, what is the speciality of each reagent and what it does. You have to remember all the reagents which oxidize under different conditions. Okay, so Dibal H will convert cyanide to CHO, and chromyl chloride will convert CH3 to CHO, PCC will convert CH2OH to CHO, K2Cr2O7 will convert OH to C double bond O. So like that we need to practice, then only you will get the answers. Okay, so this is the first set. Now the second one, these are all in-text questions only. Write the structures of the products for the following reaction. So benzene, and we are doing acylation of benzene in presence of anhydrous AlCl3. So just see the reaction, you will understand. So here you have benzene. We have done it with CH3COCl. Here you have C2H5COCl. in presence of AlCl3. So what will come on the benzene ring? Something will come on the benzene ring. So you will get, instead of COCH3, you will get COC2H5. This is a ketone where one side is C6H5, the other is C2H5. So this you will get plus HCl. Now the second one, if you remember, the second one also will give you a ketone, C6H5, CH2 whole twice CD plus 2CH3COCl. Right? What will I get? I'll get C6H5COCH3. This is also a ketone plus CdCl2. Okay, so this is also a reaction which we learn along with Rosenmund's reaction. So this is a organometallic compound. So it's very, very important reaction. Remember and learn it. The third reaction, can you tell me the third reaction product? Third one is easy. When I add water to, this is H2S of H plus, Hg2 plus, it is dilute. So it is like addition of water. So what will I get? CH3, C double bond O, CH2, CH3. You get a ketone by hydration of alkynes. And the last one is you are using chromyl chloride and water. What does it do to CH3? Anybody? We just did this reaction. What does chromyl chloride do? It will change CH3 to CHO. Okay. All of you now, before we do any more questions, let us make a list of different reagents and what they can do. Different reagents and what they can do. Let me make a list for you. So first, let us make a list of oxidizing agents. Okay, so first it is oxidizing agents. So what are the oxidizing agents that we can use? The first one is PCC. What does PCC do? It changes CH2OH to CHO. Second is copper at 573 Kelvin. What does it do? CH2OH to CHO. It can also convert secondary alcohol, CHOH to C double bond O. Please understand the reaction and these things. Then only you will be able to answer. Now it is Cr2O7 2 minus and H plus. What does that do? It changes CH2OH to the acid COOH. It can also convert secondary alcohols to ketones. Okay, these are all oxidizing agents. The next oxidizing agent is CrO2, Cl2, and H2O. What does it do? It changes CH3 to COOH. In a cyclic compound where you have a methyl group, it will change into COOH. So these are a few important oxidizing agent questions which you should remember how you do the oxidation. Oxidation to aldehydes and oxidation to acids and oxidation to ketones. All these you should know thoroughly. So we did 4 of them. Based on that only these questions were given. Okay. If I take fifth one, if I use RCOCl, what does it do? It replaces H with RC double bond O. Okay. So you have to learn these things carefully. If you write them and learn them, you will know these answers. So these are the 5 which are only for oxidation. Now predict the products in the following reactions, right? Very useful reactions. We have learned all of them. So now let us see what we will get. In the first one, what will we get? What is the type of reaction here? It is a condensation reaction. We have learned these reactions with ammonia derivatives. What happens? Water is eliminated everywhere. So how is water eliminated? You have the same compound that does not change, right? And water is eliminated from where? You can see the water is eliminated from here. O and NH and H2. This water is eliminated. So what will I get? I will get here double bond NOH. This is the product. Okay, I have taught you ammonia derivatives. You remove water, hydrogen and oxygen, and you get the product. Now you see the next one. What is the product? Again, I have to remove water. From where do I remove water? These are all ammonia derivatives. So how will I remove water? Just see this. So you have oxygen from here and hydrogen will go from here. So how will you write the product? You will get this double bond N, NH and the rest of the compound. Here NO2 and here NO2. Children, are you understanding? All of you are so quiet. Are you able to understand? This is an important chapter and just only when you write yourself, I can't see you all.
Yes, ma'am.
Okay.
Yes, ma'am.
Now here you see, again, there is an aldehyde group. What will be the reaction? The O, just see, the O from here will go and H2 from here will go. Not the H2 here, the H2 which is attached to NH, that will go. So what will you get? The product. Just write carefully the product. The product here will be R. Just copy from there. CH, double bond CH, single bond CH, then double bond N, and then NHCO, NH2. NHCO, NH2. Okay, so that is what you will get. Now the last one is a reaction of ammonia and a primary amine. How are you going to write? Everywhere you have to remove water carefully. So how will I remove water? Here, here, O is here and H is here. So if I remove water, what will I get? These are all questions that I have not created. These are questions which are there in your textbook. From here only, exactly from here, the question will be there for the exams. So this molecule and then double bond N, CH2, CH3. So you should be able to remove water and write the remaining product carefully. Okay, so these are the different products that you will get when the compound which has a carbonyl group reacts with another compound which is a what? Ammonia derivative. These are all reactions of what? Ammonia derivatives. Okay, these are all ammonia derivatives. I will ask sir if I can do something to send you the notes. I want to send you the notes. All of you should practice from there. Now this is interesting questions. Let us try and do a few of them. Now the first one, I hope all of you can see it clearly. So the first one is benzyl butane 1 to butanoic acid. So first is CH3, CH2, CH2, CH2OH. And from here, what do I want to do? I want to make butanoic acid. So CH3, CH2, CH2, COOH. So CH2OH has to change into COOH. Who will change it? Tell me.
Ma'am, CRO3.
Yes. So you will add CRO3, or you can add K2, Cr2O7 and H plus. Okay, you can even use CRO3. Then next reaction, the second one, benzyl alcohol. What is benzyl alcohol? This and CH2OH. From here, what do I need to prepare? I need to prepare phenyl ethanoic acid. You should know what you are going to prepare, then only you will be able to. CH2, CH2OH. Phenyl ethanoic acid. This is what is phenyl ethanoic acid. So from here, I need to prepare this one. How will I do it? Tell me. I need to first increase the number of carbon atoms. Look carefully. I will write first PCl5. What will I get? I will get OH will be replaced by Cl. Okay, benzyl chloride. Then I react it with NaCN. What will happen? NaCN will become here CH2CN. And this CH2CN, I can, from here I can get the alcoholic group easily. How? First I have to reduce it with tin and HCl with lithium aluminium hydride, strong reducing agent. So lithium aluminium hydride. And by doing that, I will get CH2, CH2, NH2. Right? And this one, using nitrous acid, I will get back my alcohol that I want. Are you understanding, children?
Yes, ma'am.
Ashwin, why are you so late in the class today?
Ma'am, I came little bit late from my school, ma'am.
Okay, now pay attention in the class. Now the third one is meta-nitro, 3-nitro-bromo-benzene to 3-nitro-benzoic acid. Control C. The third one we will do now. Please write the structure correctly, then you will know what to draw. So we have to first write 3-nitro-bromo-benzene. So we have here Br and 3-nitro, 1, 2, 3, 3-nitro-bromo-benzene. I have to convert it to what? 3-nitrobenzoic acid. Three-nitrobenzoic acid. Now, anyone has any idea what we should do? How I can convert the Br into COOH?
Now we can convert it to cyanide and then
Yes. So I will convert it into cyanide. How? By heating with CuCN, right? So what will I get? Nitro group here and CN here. And CN, you know, can be changed into COOH by H2O and H+. The fourth one, 4-methyl acetophenol to benzene 1,4-dicarboxylic acid. So first let us write 4-methyl acetophenol. So this is 4-methyl acetophenol, COCH3. Now from here, what I need to make? I need to make 1,4-benzene 1,4-dicarboxylic acid. So this is 1 and this is 4-dicarboxylic acid. So what I can do? I just need to do oxidation with alkaline KMnO4. What does alkaline KMnO4 capable of? It can convert CH3 to COH. It can convert COCH3 also to COH. So it's a very good reagent. It converts all carbon side chains into COOH. So that is the reagent. Then next, the fifth one, cyclohexene to hexane 1,6-dioic acid. Very good conversions and very high level. Cyclohexene, let us write cyclohexene. These are all from your textbook. And what I need to prepare from here? 1,6-dioic acid, hexane. Now it has become an open chain compound. So CH2, 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 CHO. This is 1,6-hexane, 1,6-dioic acid. 2 CHO groups are there. And I have to prepare it from this cyclic compound cyclohexene. So this cyclohexene, if I do ozonolysis, where will it break? At the double bond. So what will I get? O3, H2O and H+. So what do I get? This ring only. This is an aldehyde. Right? You get the cyclic structure. And you know the acid, this structure here, which is an aldehyde, on oxidation, it will, on oxidation, this structure is same as the one which is given here. And if I do oxidation of this one, I will get acid. So COOH, CH2, 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 COOH. So like that, I can make cyclohexene to 1,6-benzene 1,6-dioic. Hexane 1,6-dioic acid. The sixth one, butanal to butanoic acid. This at least is easy. CH3, CH2, CH2, CHO. 2-butanoic acid. What is butanoic acid? CH3, CH2, CH2, COOH. This is which acid? Butanoic acid. All right. So these are conversions. They are quite intensive. You need to read. These compounds are big. Don't bother about that. You just focus on where the reaction is going to take place And based on that, you try to find the answer. Now, the structures which are given here, first you have to find out which will undergo aldol condensation and which will undergo Cannizzarose reaction and which will undergo neither. Okay, so let us make a chart here. Aldol, here is Cannizzaro, and here I have neither. Okay, now let us look at the first one, methanol. What is the structure of methanol? HCHO. Right? Now, if this is HCHO, does it have alpha hydrogen? No. So it cannot undergo aldol, but it can undergo Cannizzarose reaction. HCHO. Then let us take the next one. What is the next one? 2-methyl pentanal. Let us write the structure of 2-methyl pentanal. Pentanal has 5 carbon atoms. And 2-methyl. So this is 1. This is 2-methyl pentanal. Right? Now will it show aldol condensation, or will it show Cannizzarose reaction, or will it show neither? Can it show aldol condensation, this compound? This compound, does it have alpha hydrogen? Tell me somebody. Does it have alpha hydrogen? Are you
Yes,
all
ma'am.
there? Does it have alpha hydrogen? It has. This one is my functional group. This has alpha hydrogen. So if it has alpha hydrogen, the second one will undergo aldol condensation. First one will undergo Cannizzarose reaction. Now let us look at the next one. Benzaldehyde. If I write benzaldehyde, does it have alpha hydrogen? Anybody? C6H5CH double bond O. This also has no alpha hydrogen. This structure, if I write correctly, so there is a carbon here. And on this carbon, you have CH and double bond O. So since there is no alpha hydrogen, it can undergo Cannizzarose reaction. So benzaldehyde will show Cannizzarose. Benzophenone. Benzophenone is what? Benzophenone is like this. On one side, it is C6H5, COCH3. This is called benzophenone. Okay. So, no, this is not benzophenone. Benzophenone is here on both sides C6H5. This is benzophenone. And this benzophenone will undergo what? It will neither undergo, right? I can take it and bring it here. It will neither undergo aldol nor Cannizzarose reaction. Okay. Now cyclohexanone. Cyclohexanone. Let us write. This is hexane. And this is double bond O. Cyclohexanone. Can cyclohexanone undergo aldol or this one? No, because ketones will not show this reaction because there is no alpha hydrogen. So they may not show the aldol condensation or this one. Let me write it here. One phenyl propanone. First write the structure. Propanone is CH3COCH3. If I make it one phenyl, then this is double bond, and here you have a benzene ring. One phenyl acetophenone. So one phenyl acetophenone can undergo aldol condensation easily. This is benzophenone. One phenyl propanone. This is sixth one. And this undergoes aldol condensation. This can undergo aldol condensation. This is the compound. It can undergo what? Aldol. Then next one is phenyl acetaldehyde. See, all these compounds, the challenge is in writing the correct structure of the compound. All of you are so quiet today, no response at all. Sanjay, Hari Raghav left. I don't know who left. Only 3 people, 4 people are there. Now tell me the next one. Butane 1-ol. CH3, CH2, CH2, CHO. Can it undergo butane 1-ol, CH2OH? Can alcohols undergo Cannizzarose reaction or aldol condensation? No. So this one cannot show the reaction. So for this one, it does not show. 2,2-dimethyl-butanal. What is 2,2-dimethyl-butanal? This is butanal. And 2,2-dimethyl, here CH3, here CH. Can it show aldol or Cannizzarose reaction? This has no alpha hydrogen. So I think it can show Cannizzarose reaction, but it cannot show aldol condensation. So I want you all to write down the reaction also. First identify which will undergo aldol, which will undergo Cannizzarose, and which will not undergo any of the 2 reactions. You have to write and practice, write and practice. That's the only way to do well. Are you able to understand?
Yes, ma'am.
Now here you have simple chemical test to distinguish between the following pairs of compounds, right? So we'll first, for the first one, we have to find the distinguishing test, propanal and propanone. You can, for one is, when one is an aldehyde, the other is a ketone, you use Tollens reagent. Tollens reagent can oxidize aldehydes, but not ketones. Second one, acetophenone and benzophenone. This is iodoform test. Acetophenone, all compounds which have CH3, C double bond O, they can show this reaction and not others. So acetophenone will show, not benzophenone. For the third one, phenol and benzoic acid, you can use neutral FeCl3 easily. Why? Because phenol gives violet color. And the other one, phenol and benzoic acid. This will give a buff precipitate. Then the fourth one, benzoic acid and ethyl benzoate. Benzoic acid. it decolor benzoic acid. This gives with neutral ferric chloride, neutral FeCl3. It gives a buff precipitate. The other one does not show the test. Then the fifth one is pentan 3-one and pentan 2-one. This can be distinguished by iodoform reaction. Please learn and write this. You can't practice just before the exam. You should learn and write. And the last one is benzaldehyde and acetophenone. You can distinguish them by iodoform test. Because acetophenone means it is CH3, C double bond O and C6H4. Okay. So this can show iodoform reaction because the alkyl group, because of the CH3CO. This can show iodoform because of the CH3CO group. All compounds which have the methyl keto group will show positive iodoform test. So these are again very useful reactions. Please note down, please learn, please revise. It's very, very important. Now a few, again, conversions, children. These are all questions from your textbook. That's why I have selected them and I want you to have enough practice. Now, first one is propanone to propene. You have to convert propanone and you have to convert it to propene. Right? Where do you get propene from? You get propene from alcohols. So how can I convert this to an alcohol? By reduction. So you get 2H. Okay, what is the reagent that you can use? You can use lithium aluminium hydride. So it will easily change CH3, CH, OH, CH3. And now if I do dehydration, CHO and H, so minus H2O, you will get propene. Now let's see. Ethanol to 3-hydroxybutanol. You have to practice these. Now, second one, benzoic acid to benzaldehyde. So this is benzoic acid. And I have to make from here benzaldehyde. Acid to aldehyde. Now, there is no way by which you can make from acid to aldehyde directly. So what I have to do? First, I should reduce it with lithium aluminium hydride. I will get alcohol. Benzyl alcohol. This is easy, a single step reduction. And now from this one, I can get this from acid by using PCC. Okay, PCC will convert alcohol to aldehyde. So these are easy steps. The thought comes only when you practice. Now next one I will not say. Somebody else has to. Ethanol to 3-hydroxybutanol. This is ethanol. And I have to make from here 3-hydroxybutanal. So this is butanal and this is 3-hydroxy. CH3, CH, CH2, CHO. How will I make this? Anybody has any idea? Just think. What I have got here is aldol to make it easier. One hint only. Sai Kalyan. Now I am taking rest. I am tired. Sai Kalyan, tell me. How can I make aldol from alcohol? Can I make aldol from alcohol? First tell me. Vaishnavi, you tell me. Sai Kalyan, I didn't hear your voice at all. Are you there?
Yes, ma'am.
Can you think of any method?
Cross-aldol condensation. Yes.
How do you make aldol? If the aldol from aldehyde, if the aldol has 4 carbon atoms, the aldehyde should have 2 carbon atoms, right? And from here, you get reacted with dilute NaOH to get the aldol, right? How can I make this from here? By using PCC, alcohol to aldehyde, and then aldehyde to aldol. Okay, so this is how you have to prepare. See, these conversions you will understand only, you will think and you will apply. The more you think and try to find the answer, the better practice you will get. Okay. Now the next one, benzene to meta-nitroacetophenone. This is benzene. And what is meta-nitroacetophenone? This is acetophenone, COCH3. And this is meta-nitro. So how will I do? First, I have to, from benzene, I have to make acetyl chloride, CH3COCl and anhydrous AlCl3. So first, what will I get? I will get acetophenone, COCH3. I told you if my functional group contains a double bond. Does COCH3 contain a double bond? It is C double bond OCH. So this is the functional group. It contains a double bond. That means it is meta-directing. So if I do from here nitration, so if I do nitration with concentrated H2SO4 and concentrated HNO3, then a nitro group will come on meta position. So that is preparation of meta-nitroacetophenone. Now the next one. Fifth, benzaldehyde to benzophenone. We should get the names correct. So this is benzaldehyde, CH double bond O. And what is benzophenone? Benzophenone is COC6H5. Benzene ring on either side. That is benzophenone. How will I do this to this? See, you know, start going backwards sometimes. So you know if I have benzene, with benzene, if I have C6H5COCl, right? This is acylation. So what is happening? One H from here will be removed and COC6H5 will come on the benzene ring. That is what we want. So I need to get benzene. So from aldehyde, how can I get benzene? Not possible. It's not easy. From here, I can first do oxidation. So benzaldehyde on oxidation will give me benzoic acid, COOH, benzoic acid. And from benzoic acid, if I heat it with NaOH and CaO and I heat it, I get benzene. And benzene on acylation will give me benzophenone. Okay, so some little imagination is required in the mind, then only you will get the answer correctly. Now the next one, benzaldehyde 2,3-phenyl propan 1-ol. Bromobenzene, did we do this? No. Sixth one, bromobenzene. This is bromobenzene. And bromobenzene 2,1-phenyl ethanol. So what is 1-phenyl ethanol? CH2CH2OH, 1-phenyl ethanol. Now somebody tell me, how can I do this? This is also a long step. Bromobenzene 2,1-phenyl ethanol.
Ma'am, by using Grignard reagent.
Yes, you can use Grignard reagent. Very good. You can use Grignard reagent.
So it will be CH3, CH2.
First what? So we need C6H5, CH2, MgBr plus CH2 double bond O. That will give me this. But now the question is, from here, how can I get this C6H5, CH2, MgBr? What you are thinking is correct, but now the hitch is bromobenzene. How can I convert it to this Grignard reagent? How will I do that?
Ma'am, I don't get your question.
Huh?
I don't get your question. Like, how,
you don't?
I cannot understand what.
So here what we will do is, first we will, like the way you did the last time, I will convert it into benzoic acid first. It's a long process. So, what will I do here? So first I will take this bromobenzene, right? And I will react it with CH3Br in presence of sodium and dry ether. Right? 2Na. So I will get what? Toluene. Did you understand? Now toluene, I will use chlorination in sunlight. So on the side chain, I will get CH2Cl. Then I will have to make it CH2CN. In fact, I can, no, okay, I'll have to do this way only. C6H5, sorry. Now I will use NaCN. So what will I get? CH2CN. Okay. And this with this on cyanide on reduction. From cyanide you can make alcohol. Let's see how. Okay, so this one you will get from here by reduction with lithium aluminum hydride. You will get CH2, CH2, NH2. And with HONO, you will get this product. So it is a very complicated one. I wish and pray that such things don't come in the exam. This all comes by practice, Vaishnavi. There is no other way.
Okay, ma'am.
Benzaldehyde 2 alpha hydroxy phenyl acetic acid. So first write the structures correctly. This is benzaldehyde. And alpha hydroxy phenyl acetic acid. So first let us write phenyl acetic acid. CH2 COOH, phenyl acetic acid. And alpha hydroxy. So here there is also OH. Alpha hydroxy, this one. Now this is very interesting. You add to it HCN, cyanide, you add to it HCN. What will I get? CH, OH and CN. And this one on hydrolysis with H2O and H plus, you will get this. I told you addition of HCN is for making hydroxy acids. So if you know the steps, you will easily make it. Now the last one, the ninth one, benzoic acid is COOH. And from benzoic acid, what do I need to prepare? Metanitro. This is nitro. And benzyl alcohol, CH2OH. On the meta position, you get a nitro group on benzyl alcohol. And I have with me this. So first what I can do, this group is meta-directing group. So first I will do with concentrated HNO3 and H2SO4. So I'll get an NO2 group at meta position. So COOH and here NO2. And now I will do lithium aluminum hydride. So COOH will change into CH2OH. That is the reaction. Done? Now let's see these. See, this chapter is very easy, but you have to practice a little to get all the answers right. Please note it down in your textbook, or after the class also, please make a note in your textbook. Now this one, I told you any carbon side chain. If I have alkaline KMNO4, what will happen? The chain will change into COOH. So I will get here this. Let me write it a little. So I made my pen a little thinner. So this and COOH. There are two carbon atoms, never mind. If I heat it with alkaline KMNO4, any carbon side chain will change into COOH. Now this one with NH2CONH, so I told you here there is always a chance of making a mistake. So the correct answer, please note down, C6H5CH double bond. There is a NH2 from here and O from here that will go. So what will I get? C6H5CH, and then from the other side, NNHCONH2. What is this huge compound? It is made from semi-carbazide. This is the most difficult reaction in the whole chapter. You have to remember how to get the final product. Now this with AgNH3, so this is a oxidizing agent which will not oxidize the carbonyl group. It will not oxidize the carbonyl group. See this? There are two groups here. This group will not get oxidized. This will get oxidized. So here it will remain as it is. It doesn't affect ketones. But here CHO will change into COOH. Now the sixth one you see here, C6H5CHO and CH3CH2CHO. Let me see who can write it correctly. Let me take it on the next page. So okay, so I have to now look at the seventh one. So it is C6H5CHO plus CH3CH2CHO. Okay, so alpha hydrogen, the second one has alpha hydrogen. Where is my alpha hydrogen? It is CHO and here CH3. Why did I take out this hydrogen? This is my alpha hydrogen. And this carbon is functional group. So the carbon adjacent, this is alpha, right? So alpha hydrogen will react. Now, how will be the reaction? To write the reaction or understand the reaction, I told you what? Add the H here and the rest of the molecule will come here. So what is the product that I will get? C6H5CHOH and here CHO and one CH3 here. So that is the major product here. Remember, aldol condensation. The carbon which has the OH and the CHO group should be separated by one carbon atom. That is how you get the answer. Next is this one with CrO3. CrO3 is what? It is also an oxidizing agent, will convert alcohol to a ketone. CrO3, it will oxidize it to a ketone. Okay, this group gets oxidized. Hydrogen is removed. One from here and one from here, so you get a cyclohexanone. Then the ninth one, this is ninth, and then the 11th one. What is the 11th one? You are doing which compound? See, look at the 11th one. The question is which compound gives this on ozonolysis? Only this, two molecules of this. Which compound gives this on ozonolysis? So it is easy. You connect two benzene rings like this. Two benzene rings with a double bond. You connect two benzene rings with a double bond. So if I do ozonolysis, H2O and zinc dust, it will break here. I told you where there's a double bond, cut it. So it will break here and you will get this compound, 2 of them. Okay, so that is the 11th one. Now today's session is tiring. Careful. This one with SOCl2, what will you get? What does SOCl2 do? It replaces, tell me, it replaces OH with Cl. So COOH, it will become COCl and COCl. Okay, so this you get plus 2SO2 plus 2HCl. These will all evaporate as gases. You will be left with this compound. Then starting material, reagents and products. Here we'll use PCl5. Now you have to get benzene. From benzene, you have to prepare C6H5, COC6H5. So how can you put this group here? By acylation, C6H5COCl. So with anhydrous AlCl3, Friedel-Crafts reaction. So you will get this. Now the 6th one. This is a big compound. Let me write it in the expanded form. This is called ester, acetoacetic ester, CH2, C double bond O, O, C2, H5. Now here what I have to do, I have to reduce the carbon-oxygen bond. So carbon-oxygen bond, which is not, which is only the part of the carbonyl group. This is the methyl keto group. So I'm looking at only this carbonyl group. This carbonyl group, I don't look at it because why? Because there is resonance here. This double bond is either here or here. So this area is very stable. So reduction will take place only on this carbonyl group. So if I reduce it with NaBH4, it only reduces aldehydes and ketones. So what will I get? CHOH, CH2, C double bond O and OC2H5. If I had taken instead of NaBH4, I had taken lithium aluminum hydride, it would have oxidized, reduced the acidic group also. Now it is reducing only the aldehyde because it is NaBH4. The last one I can write here itself. This one is I have to get a CHO here. How will I get a CHO? Alkene is there. So alkene, how can I convert the alkene? So what will I do first? First, I can add to it I can make it into CH2OH. So I have to add here water. H. How will I add water? Here, if I add the C, so H will come in the middle. I can't do that. I need to add OH here and H here. So I can do the easier thing, I will tell you. I will add HBr in presence of peroxides. So what will I get? I will get here this and here CH2Br. And then I will add aqueous KOH. So I will get the benzene ring and CH2OH. And now I will use PCC. No, not the benzene ring, only this. No benzene ring, sorry. Can you see? And here I will use PCC. So I will first convert it into an alkyl halide and then with aqueous KOH remove the Br and then do PCC to get this. Why did I add HBr in presence of peroxides? If I just add water here, what will happen? I will get this compound, which I don't want, right? If I just add water, I will get CH3 and OH will come here. I want the OH to come on the terminal carbon. Then only I can do oxidation correctly. So I will get CHO here. So that is a little tricky. That's how. Okay. Now, this is also from your textbook. All this part is from the exemplar one. So let us see how to do this type of questions. These are a little easier compared to the ones which we have done. They are also application oriented. See, organic chemistry here, you can do well by doing lots and lots of questions, and they should be just application. You should understand what is happening, then only you will be able to get the answer. By practice, only practice. I took up this today's one class I have taken completely for this because I realized that there are a lot of questions which you may need help. Now let's look at this question. An organic compound contains carbon, hydrogen, and rest oxygen. The molecular mass of the compound is 86. So first I have to find the molecular formula of the compound. Have you learned in last year, you have learned how to arrive at the molecular formula. So carbon, hydrogen, and oxygen. How much is carbon? 69.77%. How much is hydrogen? 11.63%. So how much will be oxygen? First add these two, 69.77 and 11.63. So 0, this is 4, this is 1, and this is 7 plus 1, 8. Now how much is oxygen? 100 minus 81.40. Right? So what will that be? 0, 6, and 9 minus 1 is 8, 18.60. Children, do you remember doing this last year? Have you done this? Tell me.
Yes, ma'am.
Sai Kalyan, have you done these questions last year? Now, Sai Kalyan, quickly. Vaishnavi and Sai Kalyan, tell me what will be the answer. First one, so you have to find the approximate ratio. So for that, you divide by the atomic mass of these. So carbon is 12 and hydrogen is 1 and oxygen is 16. So 69.77 divided by 12, how much is it? It is 5 point something, isn't it? 5,
5.8.
5.8. And this is 11.63. And this will be how much? 18.6 divided by 16. It is 1 point something. 1.2. 1, 2. Okay. 1.6. Now, what is the next step that you do? Tell me. You divide everyone by the smallest number. What is the smallest? 1 point. So 1.16, 1.16, and this also 1.16. So here what will I get? Here I get 10. Here I get 1. What will I get here? I think it should be 4. Or 5. Not 5. It is 4 only. C4H10O. So the compound, organic compound, which has molecular mass 86, it is C4H10O. Is it 86? No. So this is 48 plus 10 plus 16. So 14. How can it be? The molecular mass of the compound is 86. Can you tell me the answer of the first one? 5.8 divided by this one, how much do you get? I didn't hear you. 5.
I'm telling
5. So this is C5H10O. So C5H10O. So 5 is 60 plus 10 plus 16. So this is 86.
86.
Right. So formula of the compound is C5H10O. Right. Now it does not reduce tolerance reagent. What do you understand by that? It does not reduce tolerance reagent. It does not reduce tolerance reagent. What do you understand by that? That means it is a ketone. It is not an aldehyde, but it is a ketone. This formula is CnH2nO. So it is either an aldehyde or a ketone. So we know now what is it? It is a ketone because it does not reduce tolerance reagent. It forms addition compound with sodium bisulfite. That means it is a carbonyl compound. Gives positive iodoform test. If it gives a positive iodoform test, what should it be? It should be a ketone which should have CO group. Now, if I take out CO group from here, 2 carbon atoms, what will I be left with? CH2, CH2, CH3. So it is what? 2-pentanone. Right? On vigorous oxidation, what will it give? Ethanoic acid and propanoic acid. Why? Because it will break here. And one component will form ethanoic acid. The other 3 carbon atoms, it will form the propanoic acid. So it is 2-pentanone. Okay, so the answer is 2-pentanone. These come under 5-mark questions, children. So please revise and understand and practice. Now only 2 special children are waiting, Sai Kalyan and Vaishnavi. All of them has gone above them. I don't know what to do. Next one. Compound A and C are in the following reaction. What are compounds A and C? So first is CH3CHO and MgBr. This is, I suppose, a little easier. So let us see. So what do I get? CH3, CHOH, and here CH3, secondary alcohol. With concentrated H2SO4, what will I get? I will be able to remove water. So it will become propene, CH3CH double bond CH2. And with hydroboration oxidation, anti-Markovnikov addition, CH3CH2 CH2OH. So what are C and A? They are positional isomers. OH was on the second, here the OH. This is 2-propanol, this is 1-propanol. So 1-propanol and 2-propanol, what can they be? They can be position isomer. Position. Now, which is the most suitable reagent for the following conversion? In this conversion, what have I done? I have Benzoyl peroxide. So most suitable reagent is iodine and NaOH. Tollens reagent, how did I find? Tollens reagent cannot because it only oxidizes aldehydes. Benzoyl peroxide, it's anyway not an oxidizing agent. It is used in addition of HBr in presence of peroxide. Tin and NaOH, it reduces nitro group to NH2 group. So only thing is NH2 and NaOH. This is a iodoform reaction. Iodoform reaction, where does it work? Where you have this group, COCH3 group. So you will get this as a product. So this is the last question for today. We took almost 1.5 hours to solve all this. So C5H10. Okay, C5H10. So you have C5H10. C5H10, when you look at it, what do you understand? It is an alkene.
Alkene.
Right? Now what will you know? It is mixture of two compounds B and C. Compound B gives positive Felling's test. So it gives alkene on ozonolysis. It gives B plus C. And B gives positive Felling's test. That means B is an aldehyde. And C gives a positive iodoform test. So it is Felling's and also forms iodoform test. So this is an aldehyde. Only one aldehyde gives a iodoform test. Which aldehyde can it be? Do you know? It is CH3CHO. Only one aldehyde gives. I told you. C double bond O and H. So B is this one. Now, C does not give Felling's test but forms iodoform test. So C will be CH3, C double bond O, CH3. So this is ethanol, this is propanone. So what will be C5H10? C5H10 will be CH3, C, H double bond C, CH3, CH. Can you make out? This is your alkene. And this alkene will give me this plus this. All right, children. Thank you very much for bearing today. It was tough, but go through this and try to write the answers yourself. And then we will. So next class, I will start kinetics. But for that, before you start kinetics, you should completely understand this. I can give you easier questions. I will make an assignment and slowly build up. But all these questions are from your textbook only. So you can imagine how much practice is required to do well in this chapter. Okay. So we can practice again after 1 or 2 weeks. We can look back again and help you more if you need it. Okay. So Sai Kalyan and Vaishnavi, and thank you very much for staying throughout the class. And Hari Raga for joining towards the end. Thank you very much. Okay, bye.
Ma'am, can we also revise the alcohols lesson later?
Yes, definitely. I will revise the alcohols. In the next class, I'll spend some time on alcohols. Okay?
Yes, ma'am.
Okay, bye.
Thank you.
Thank you.
Thank you. Thank you.